on a workbench, this is what Alumina ceramic looks like in production. Round, square, single bore, multi-bore, large, fine. Same material, same chemistry. But none of these tubes exists by accident. Each shape, each wall, each finish was decided by what the tube has to survive once it leaves the factory. Take a single bore tube. The bore protects a thermocouple element from the gas, the heat, the molten splash inside a furnace. A square cross-section gives flat mounting faces, useful where the tube becomes part of a structural assembly, not just a passive sleeve. Multi-bore tubes let several thermocouple wires share one sealed entry point, so a 4-zone furnace doesn't need 4 separate feed-throughs through its wall. The geometry is a response. It changes when the operating condition changes, when the temperature rises, when the atmosphere turns corrosive, when more signals have to pass through less space. ADCERAX produces alumina tubes in 3 working grades. 96% alumina handles continuous service up to about 1,600 degrees Celsius, and it carries the wear and insulation load in routine industrial environments, flame tubes, general furnace work, lined pipe. 99% is the middle grade, certified to IEC 795. It buys higher flexural strength and a cleaner microstructure. And 99.7 the high purity grade, IEC 799, pushes continuous operation to 1,730 degrees Celsius. That grade is what semiconductor diffusion furnaces, precious metal thermocouple sheaths, and vacuum systems are built around, because outgassing and contamination at those temperatures are no longer abstract concerns. The shape of every tube starts as a pressed or extruded green body. For round tubes with consistent walls, extrusion is fast and efficient. The powder, bound and plasticized, is pushed through a die at controlled pressure. For complex cross-sections, including square profiles and multi-bore patterns, isostatic pressing distributes the forming pressure from every direction, which keeps wall thickness uniform across geometries the extruder cannot reach. Then sintering. The green body holds its dimensions while temperature climbs and the alumina particles fuse into a dense, vitreous structure. For 99.7% material, that sintering atmosphere matters. It controls how much the body shrinks, how dense it ends, and whether the surface seals or stays porous. After sintering, alumina is harder than most cutting tools, so finishing is handled with diamond-based machining. CNC grinding, fine grinding, and lapping are used to control the outer diameter, inner diameter, end faces, and bore concentricity. If the tube needs a smoother internal surface, the bore can be polished after grinding instead of being left in an as-fired condition. This finishing stage removes firing variation, corrects critical dimensions, and prepares the tube for inspection before packaging. If you already know your operating condition, temperature, atmosphere, applied voltage, dimensional envelope, what failed last time, send the drawing or a description of the part you need. An engineer reviews the requirement before the quotation goes out, so the answer addresses your application, not a generic catalog. Standard sizes ship from stock in 24 hours. Custom builds typically run 3 to 5 weeks. ADCERAX, Advanced Ceramic Manufacturer. Real shop floor, real engineering. Talk to us.